All right, now for the fun stuff. So, the model tool. We'll give a little bit of background on it, then I'm going to break it out and actually walk through kind of the actual, Excel slide worksheets with everyone. So what this model tool is, we really wanted it to be a tool to enable risk assessors to enter their own data, and then have the model provide the factors to provide those bioaccumulation estimates, get into the food web, pull out TRVs, and calculate, their exposures and hazard quotients for wildlife. It's a customizable multi-worksheet Excel file. It comes with a user's manual. Don't know if any of you read it, but try to when you get a chance. Really, right now, it's a beta version. We'd love feedback on it. If there's things that you think can be improved, you find anything that you're just not sure about, please let us know. We tried to, make it adaptable for both T&E species and common species because while the scope of the work we were doing for the CERTA program was focused on T&E, most risk assessments are focused on common species, really. And so we wanted this to be usable for both. We are working on a terrestrial version, and hope that will get posted to the CERTA project page when it's ready as well. And, as a bit of a warning, everything in this Excel file is editable, so, which is great. It means if you, decide, hey, I really didn't like that BCF you recommended, but I like this one from your appendix, I want to use this one instead, you can do that. You just have to be careful because as you work in the model tool, it can break it pretty easily as well. So we do recommend kind of saving a copy somewhere before you start playing around too heavily in it. So the model's based on the guidance document. It's intended to facilitate site management decisions by generating, quantitative outputs for the potential for direct effects to aquatic communities, the predicted concentrations in the food web and in wildlife diet items, and then, ERA effects assessment and risk characterization. So it goes as far as calculating your hazard quotients where we've got TRVs. It is not really meant to just be a plug and play, do your eco risk assessment all, without actually talking to, an eco risk assessor. We, really don't recommend this tool for just, site managers who have no experience working with ecological risk assessment because there is a lot of judgment that has to go into, the parameters and the values. It's not to be used as a standalone cleanup value calculator either. I mean, you certainly could run it backwards and get to a risk-based cleanup level, but these are pretty conservative assumptions, and it's not really intended for that use right now. I'll throw this caveat out there that, we do expect that folks using this model assume all responsibility for the inputs in it. We've made our recommendations for what we think are good values here, but, use your best judgment for your site. So the model does come with a user guide. The user guide includes a breakdown of each Excel worksheet with detailed instructions on selecting receptors, adding in site-specific data, and selecting whether or not you want to select for using surrogates or not throughout the process. It includes screenshots and lots of details on how to actually operate the model. But it doesn't include the technical background for it. All of the kind of background, a lot of what we've been talking about today, that you're going to actually find in the user guide, the guidance document itself, not in the user manual for this tool. All right. So we're going to start with an introduction tab because that just kind of makes it easier for everyone. So this includes a little bit of background on the model, a bit of background on the guidance document itself. It's going to include kind of the model version. So when we go from beta to, an official version or we do updates, we're going to track it on this tab as well. So you can see when there's new versions out on the web page. It includes citations for you and some, very important links. Jason's email when you want to harass him with questions, feel free, along with a link to the CERTA project page itself. The next tab we included is a table of contents, pretty straightforward. What it does is goes through each of the tabs and sort of what they do. It includes sort of a brief description of kind of the goal of what that tab is. I love color coding things, what can I say? So anything that's related to exposure is color coded in blue. Anything that's related to effects is color coded in green, and all of the risk characterizations are color coded in yellow. So all of the tab colorings along the bottom correspond to kind of what that tab does. The other key thing is that throughout this model, where there is a user action needed, so where you need to insert your data, where you need to make a selection about surrogates or put in your organic carbon content, anything like that, something where you need to put a value in, we've highlighted in this really bright green color. So we're hoping that it kind of really quickly draws folks' eye to where they actually have to do something. And we've also included on this TOC tab what those user options are. And also up here, what we've got is a table of a spot for your site name. And this is just kind of to make life easier. So if you put in, test site here, it's going to carry it through the rest of the tabs, so you don't have to enter it for each table. Acronyms and abbreviations, of course. We didn't want to include them on every tab, so we've just got them here. And then we get into these blue tabs, and these blue tabs cover the exposure side of things. And so the very first tab here is the exposure factors. And so folks who've done a lot of eco-risk assessment, you've probably seen or developed tables similar to this many, many times. This goes through what your receptors are for your site. It includes body weight, daily food ingestion rates, and then the breakdown of what those proportions of each diet item are. Includes the sediment ingestion rate, drinking water ingestion rates for those receptors, home ranges, and area use factors. So a couple key features on this tab that we want to walk through. First is the fish diet is open for interpretation right now. We've got a few example fish species in here, bluegill and mamichog, and then we've got a few predatory fish examples in these drop-down menus. Depending on which you select, really just alters the fish home ranges at this point. The diet items, are open for user input. I will note down here, if, for example, say you don't have a dietary proportion that equals 1, the model is going to give you this little warning and tell you that your fish isn't eating 100% of its diet, and something's wrong with what you've assumed at this point. We'll just go back. There we go. So the other couple things to point out on this tab, so you get into then the avian species. So these drop-down menus allow you to select from what we've got as kind of pre-selected receptors. Generally, they're common species. We've got a few T&E species in there as well. You're not bound to these receptors. You're certainly welcome to adjust this worksheet to be able to put in whatever receptors you're looking for. But we wanted to include just some kind of standard receptors that we've often used at our sites to get people sort of something easy to work with. When you select from these drop-down menus, the rest of the exposure parameters automatically update. So these are all pulling from one of the further back internal tabs. And you'll see there's an exposure factor lookup tab. And this here includes pretty much all of the exposure factors that will get pulled in for any of those receptors. It also includes, the reference for it and any important notes that we thought were relevant when we were including it. So if you want more information on, well, where did they come up with that body weight for Canada goose, or how did they come up with that, sediment ingestion rate? You'll take a look at the exposure factor lookup tab for all that extra information. So you can go through and select each of your receptors depending on what you have kind of decided based on your conceptual site model. And it includes sort of one of each of the general feeding guilds for each of birds and mammals. So a herbivore, an invertivore or omnivore, and a piscivore as well. And so we're trying to kind of capture all three major exposure routes here. There is an area up here to place your site area in. The site area obviously gets factored into the area use factor for your organism for each of these receptors. And that's calculated in the model down here based on the home range provided in the lookup tab. Certainly there are instances where you may have a site area that's, say 100-acre larger area, but you know that your receptor only actually forages right along the shoreline in, say, water that's under 6 inches. And so you may have, for some receptors, area use factors that are very site-specific for your site. In that case, you would just go ahead and input them directly into the area use factor row rather than necessarily using the pre-calculation that's in there. And that's just to kind of, allow you the flexibility of making this as site-specific as you need to represent the receptors at your site. So the next sheet that we include here is the Bioaccumulation Parameters tab. And what this has is really it just outlines what all of our selected and recommended parameters are that we've been talking about all day, basically. So we see here we have values for aquatic plants, so BCFs for aquatic plants, water to pelagic invertebrates BCFs, sediment to benthic invertebrate BSAFs, water to fish tissue, and diet to fish tissue BMFs. References are included as well. And the key thing to kind of do on this tab for users is to decide whether or not you want to apply those surrogate values that we discussed earlier. And so really all you have to do that is put a yes into this tab here, this green cell, and it's going to automatically pull in what our recommended surrogate options are. Anything but yes in that tab, and it won't work. So it's a yes or a nothing. These cells aren't highlighted green, so there isn't a need to input them. But we got the comment earlier that sometimes field BAFs may be more representative because there's a lot going on in the field of confounding factors compared to these lab BCFs. So this is this would be the tab where if you have either a site-specific BSAF that you've calculated in a lab or in your field, or if you have a value from the literature that you're just like, well, this really is this is the receptor I want. This is from a field study that looks a lot like my site. This is going to be better than that lab study. You would go ahead and enter it into this tab, and that would allow you to kind of make this a little more site-specific. So the next tab is our data input and food web model, and this is kind of where all the magic happens, really. This is like the big fun tab. This is where you put in all your data. This is where much of the food web modeling actually happens and occurs. So the first kind of thing you want to select is your organic carbon concentration for your site. We'll use an average here of 1%. This does need to be in fraction, not percentage. So just note that. That is the one area where this model is not set up to be flexible. You need to use the units that we have in here. If the water water needs to be entered in nanograms per liter, and sediment needs to be entered in nanograms per kilogram dry weight. So for example, here you would enter in, say, you've got your concentrations from your lab. I'm just going to put in some dummy values here. And it might just be easier to do this. And then we've also got a basis tab here, or option here as well. And what we meant for the basis really is just, are these your median values, mean values, 95 UCLs, maximum concentrations? This is something as ecological risk assessors, we want to make sure we know what our EPC values are and what we're using to represent our site. So you would want to just kind of put in, this is my max concentration if I'm being, very conservative today. I'm going to put some dummy values in for water here, and what you'll see is as I start putting in water and sediment concentrations, the bioaccumulation model is going to start filling out all of the values. Just do 10 for sediment. It's going to start filling out all of the values for the rest of the food web model. The other thing that's really important here is that what we have is kind of what we're calling the mini models built into this, and those are for the forage fish and the predatory fish. So if you recall in that CSM when we were talking about the bioaccumulation model, concentrations in plants and invertebrates and in Pelagic and benthic invertebrates, they're all based on very simple equations. It's your BCF times that concentration in the media. But the fish get more complicated because they're exposed directly through the water itself, but then also through all three diet items. So these kind of hideable, these are, collapsible and openable mini models that walk you through each component of that fish uptake. And then it sums it here to provide what the total concentration would be. And so this can be useful for a number of things. One, obviously it's kind of needed to get to that total value, and it's a nice way to kind of break it down, we felt, step by step for users. But also what it allows you to do is kind of look at where your major exposure pathways are. Is it mainly through the diet for these fish, or is it mainly through the water? You'll see something similar for the predatory fish, but we've added in a forage fish option as well, because those predatory fish can eat the smaller fish as well. The other important aspect of this tab is that if you have gone out and collected site-specific tissue data for any of your media, whether that's plants, invertebrates, or fish themselves, you can go ahead and enter that in these green cells. And in subsequent tabs, the model is going to selectively use your measured data over any of the modeled parameters. So if you do have measured data, it's going to take your measured data above all else. And what we really see there, we'll see that mostly in the EPC tab. And that's where, so for example, if I put in a measured data, I'm going to put some measured values in for our benthic invertebrates. Let's say just by pure luck, they all ended up being 100 because that's faster. So then on the next tab, which is our EPC tab, you'll see that that value of 100 got carried in and is identified as our measured value. And so this tab really provides kind of a table that allows you to just have a very quick summary of what your exposure point concentrations are. What we have here, for example, is all of our modeled values. We've got measured values, and if you had put in, your EPCs for sediment and surface water, and they all get carried through. One thing I want to talk about in a little more detail is some flagging we've included to identify when your estimated concentrations in fish are maybe underestimated. So if, for example, we decided we didn't want to use any of these surrogate values, we just don't trust them, we think it's too uncertain, which is totally okay. But what that does mean is that when you go to look to the concentration in your forage fish, for example, for PFBA, for example, we won't be able to have an aquatic plant component because we don't have a BCF for it. And we won't be able to have a pelagic invertebrate component or a sediment invertebrate component. So when we actually go to see that forage fish, we don't have biomagnification from plants or invertebrates or benthic invertebrates. So what the tool does is it identifies that some of these values were left blank with potentially underestimated. So we have these little PU flags throughout the document, or throughout the workbook, that calls out when, for example, some of these values are not being included. If we were to go back and use our surrogate values instead, what we see is that these little flags have all gone away. And so that's really, it's really just kind of so you can, as a user, track where you maybe have more uncertainty. So when you go to, discuss this with your stakeholders, if you've decided, you didn't want to apply those surrogate values, you can say, here's where these values may be underestimated. It's because we didn't have these parameters for this component of the food web. And those values are also carried forward in the EPC tab as well. So you can see here our modeled values for forage fish and predatory fish. Because we were missing some of those bioaccumulation parameters, they're potentially underestimated. So the next two tabs here are TRV tabs. I'm actually going to start with mammals, even though birds comes first, because it's just more robust, as we talked about. Again, so these tabs, these tables, we really wanted to try to include as much information, kind of an understanding of what the basis of each TRV was. So it provides the TRV value, We have a low TRV, which is generally that no effect value. And then we have a high TRV, which was that next value up in those graphs Jason was discussing. We've got kind of what the basis was, so no effect on growth identified as body weight in rats, or a 14% control-adjusted decrease in survival. So we're hoping that you could be able to communicate what those magnitudes of effect are and show these in kind of the tables you've got provided. What we have included is, as we talked about that surrogate option, where we've been looking to the adjacent carbon chain length PFAS, and then within the PFCAs or PFSAs, and applying whichever the more conservative of those two were. So if this green cell, again, if this is blank, you're just going to have no TRV listed where we don't have a TRV. So for example here, you'll see there's nothing listed. But if you do decide that you want to try and apply those surrogate values, you just put yes in that green tab again, and it will self-populate with all of the available TRVs, along with a note as to which chemical was being used as a surrogate value. As Jason mentioned, we are happy to have you pick your favorite TRV here and use it, for what makes sense at your site. So we've got these last two columns here where you can put in your own TRV. We do encourage you to put some notes as to what that represents for, communication to your stakeholders. But these are available and highlighted so that if there are TRVs you prefer, it's open and the model will work with all three. So if you do have input user TRVs, the model is going to calculate you 3 hazard quotients, basically, an HQ low based on our recommended, an HQ high based on our recommended where available, and then a user recommended hazard quotient. For birds, very similar table you'll see, but unfortunately a lot more no TRVs are in this one. As Jason mentioned, we didn't feel that given the lack of data for avians, we just didn't feel like there was a good surrogate approach here for the PFCAs and for the PFSAs. There just wasn't that, there weren't enough TRVs to be able to apply that look to both directions and see approach. And we didn't feel comfortable just applying the TRV for PFAS, for example, across the board. We felt that was just overly conservative. So what you can do, though, is you can say yes in this cell, and what it will do is apply that surrogate value, applying that TRV for surrogates for precursors, apply the value for PFAS to all of the precursors. Again, though, we have user input TRVs, so if if in the next 2 weeks this great paper comes out and you're like, that's the TRV I want to use, then that's the spot to put it in, and we'll be happy to see those come in. Most of these tabs are all sort of set up to be relatively easy to print and, provide kind of tables to go into whatever report or documentation you're working on as well. So hopefully we're making your lives easier. So all of these yellow tabs then get to risk characterization. And we pretty much have, one for direct contact and then one tab for each of those three bird receptors that were selected and 3 mammal receptors that were selected. So in the direct contact table, what you'll see is that unfortunately we only have those few TRVs where we had species sensitivity distributions or had enough data to develop the species sensitivity distributions. So we have values for PFOA and PFOS here for the TRVs. As Jason noted, we calculated those based on freshwater or marine organisms separately. So really all you have to do here is decide, or not even decide, put in which value is put in X for either marine or freshwater, depending on what your site is. If you have marine selected, unfortunately, we didn't have a TRV for PFOA because we didn't have enough data to support a species sensitivity distribution for marine organisms for PFOA, so that value does disappear. If you do have freshwater systems, we have one extra TRV for you to use. So these first two columns, lists out the EPC from your data input tab, includes the aquatic life TRV, and then calculates your hazard quotients of the ratio of the two. For all of our receptor tabs, so we have 3 tabs for birds, 3 for mammals. They're pretty much identical. What they do is walk through pretty much the whole process. We really wanted to make these tabs kind of able for users to take a look and really get all the information in once. So it includes both the EPCs for each media. So these are your modeled or your measured or your predicted concentrations in sediment, surface water, vegetation, pelagic, benthic, invertebrate, and your 2 fish. And then for each of those media, it calculates the total daily intake for that specific media. And this is, mostly just how we like to have always done our kind of risk assessment calculations, because what this allows you to do is identify which particular diet item maybe is driving your exposure for that organism. It can help you further refine, what your next steps are at the site or what tissue data might be critical for you to collect. We were talking a little bit about relative bioavailability. We've assumed 1 for this model right now. These are adjustable if new data comes out to support a lower bioavailability, but to be conservative, we've defaulted to 1. Each of these tabs will list the receptor that you selected in that exposure factor tab right at the top. So you'll see sort of which you're looking at. And then it calculates 2 area use factors. And these are to account for the consumption of fish outside of the site area, but that may have been exposed to the site. So if your fish has a home range that's larger than your impacted area, you might have a fish that's swimming in and around and accumulating PFAS and then going outside your kind of your site area as you've defined it here. But you could still have a bird that eats that fish outside the site and still have some exposure that way. So these 2 area use factors account for that. And I won't get into the math, but you can look up Conder et al. 2008 or shoot us an email and we'll send you that paper if you'd like more information on how exactly those get calculated. And then for the total daily intake, again, is for each media is calculated using that really standard equation here, and we've got this included just for clarity. These will pull in specifically what your exposure factors were selected for each receptor. So in theory, you could take this table and do a hand calculation from this as a QC to understand if everything's working right. So it goes through EPCs and total daily intake for each media. And then it includes the TRVs as selected or as recommended, and then hazard quotients calculated from the low and from the high TRV. Again, where we had those bioaccumulation parameters, if we weren't including those surrogate values and thus maybe have some values for some PFAS that are potentially underestimated, those are again going to be carried forward into these tabs as just kind of a flag for you to understand where maybe things are being, adding a little bit more uncertainty. Right now, we have the user-selected TRV columns hidden, assuming there's nothing, not being entered. But if you have entered a user-selected TRV, those will be included here in column X, and your hazard quotient calculated based off that TRV would be included right next to it. These tabs are all sort of set up in the same framework. So really, all that changes is what your receptor is at the top. And then, of course, the total daily intakes are calculated based on the receptor-specific exposure factors. And those are updated at the bottom of every tab as well, just to keep kind of internal tracking of what your parameters are for your modeling. And so we have our 3 birds. And then we've got our 3 mammals. And you see the same thing here. We've got our receptor of muskrat. Got where we have NAs, we do see our potentially underestimated flags at the end. And we see, lastly, we've got our last 2 mammal tabs, all sort of set up the same way, so I'm not going to go through these in too much detail. The last 2 things that we've included are a summary table of your hazard quotients. Nothing for you to have to do here, but just, it's a nice summary table to include, for reporting purposes. It provides all of your hazard quotients for all of your different receptors. If you've used user input TRVs, again, you just have to expand the table to see those included. And lastly, we've included this figure here. This gets auto-populated, so you don't have to worry about making it. But what it really does is kind of breaks down, there we go, breaks down the distribution of PFAS in the total daily intake of the 6 receptors you've selected. So it can just be helpful to see, is PFAS driving the bioaccumulation and the risk and the exposure at your site? Is there other PFAS of concern? I put in dummy values here, so it's all over the place, but I think at most sites you'd probably see PFAS dominating this bar chart. And so that is, I guess lastly I'll just note there's some internal tabs, that exposure factor lookup tab, along with some supporting tabs for this figure as well. So those are kind of just internal. They don't need to be included in reports, but are just there to kind of keep everything functioning and working well. And so that is the tool as we've kind of got it developed. Happy to have people play with it and provide us feedback, make recommendations, let us know if it's working for you.